This conference will now be recorded.
So we are now recording. All right. How are things going?
Going okay. Chris is here. He's been working on the machine pretty much all day. Saw a few things that he thought may be causing it to act up. He's done another ball bar test, and they're still working with it. I think they're still having some issues with the height setter. I thought we had those all resolved yesterday, but it seems like some of the same issues have come back somehow.
Mm-hmm. All right. Okay.
So I got a few questions for you. If you don't mind if I open a file right quick.
Yep.
Something I was working on. And I'm likely going about this the wrong way, but I'm trying to learn and self-teach a little bit as well, watching your videos. So One thing that I had trouble with is I had created some small parts, roughly 2-inch square, half-inch steel, and I wanted to put a tab on them, but I created them in the 3D 5X and did the toolpath with a lead in, overcut, lead out. And when I tried to add a tab, I could not successfully add a tab. But if I used a DXF of that part and created the part in the interface we're looking at now in this section of IGEMS, I was able to use, I think it was CAM and Contour.
Right. Yep.
And I added a 60,000 tab, and then I could select that point.
Right.
So that's how I did this particular part. And I've got it tabbed here because this is the area that's not going to matter. It just has to clear a weld to be a gusset.
Mm-hmm. Yep.
But I didn't know if this part was created from the 3D 5X, if there's a way to add a tab after the fact, and we can look at another part at some point.
Yeah, you can do that once you pull up something, and we'll run through that.
It may not be a great example. It's just probably going to be a bigger part than what we would actually encounter. But
all right.
This is probably an 8-inch part with a bevel on it, so it likely will not be tabbed. But the only thing I could see where I would tab a part like this, and I did see this in one, is the piece of 3/4 stainless plate that I have on the table has some pre-stress in it. Obviously, is quite warped. So if I needed a more consistent cut, if I'm not mistaken, I would probably need to put a few tabs on it so that it would try to hold into the plate better instead of trying to move during the cut.
Right. Yeah. Or you do your you do the bevel cut first, and then the first cut you do when you're going around the outside would be that cut along the bevel side, so it's they're fully attached in the plate. But if you do need to add a couple more tabs, you can do that. So yeah, so we'll just take this back into the 3D world here. So yeah, so like if you wanted to add a tab up here and down here, we can do that through the hold on, my son is looking for something. Yes, Lou? Yeah. Okay. Okay, I'm on the phone. Okay. All right. So if we go into the cam area.
If you need to take care of something, Mr. Jeff, that's not a problem.
No, he's just, we play part-time educator and part-time job.
I understand. I've got a 3-year-old. She hates it when I get on the computer or the phone.
Right. And can't send them off to daycare this summer like we normally would.
Right.
So, all right, yeah, so if we want to add a couple tabs on the outside here, so there's this button here for micro joints. So you can click on that, and then this would be the width of that tab there, so however big you want to make that. And then jet on off means it's going to do individual pierces, so it'll stop and then move over and pierce and start the next cut. And then this would be the length of your lead in and lead out for the tab. So I'd probably make it like 0.18 long and don't need much in the way of a lead out, 0.06 maybe. And then the type of piercing that you're doing and tilted piercing. So then you click on add, and then you just click where you want to put those. So it'll basically, let's hit enter here and close that. And if you ever need to get rid of one, they've got the delete option here. So if you decided you didn't want this one here, you can click on delete. And then as you hover near these, they get highlighted. And so if you want to get rid of that one, you just left click and it goes away.
Okay.
So we'll put that one back in there.
And you did this through toolpath and then micro joints. Okay.
Right. Yep.
That was the button I missed. I was trying to use the micro joints. I'd read through the manual and looked at some of your videos, and I saw the micro joints tab in the other, on the, I guess in the 2D world screen, and it wouldn't do anything for me if I had created it in the 3D 5X side.
So of course we got our rep. So in one of your emails you had mentioned wanting to lift higher. So of course, that can be controlled here. The initial move up is controlled in the post. We can change that. But of course, this is between cuts. So, if we did want to make those higher, you can just change that to whatever height you want those to be.
My major Z height issue there that I mentioned in one of the emails was during height setter, and Rob, and I think they're working on it still today a little bit. What was happening is when, basically I could place the nozzle close to where I thought it should be, and then when it would run height setter, it really had it made the rotational movement to bring the height setter probe to the point of the nozzle before or during the time that it was raising up in Z. So what was happening is the nozzle I just happened to be looking at it one time and it swung and missed one of my clamps by maybe a 1/16 of an inch.
Right.
So what they did is they programmed it to where it would go up in Z before it started to do the rotation, come back down, go back up, rotate back, and then come back down to make sure that the system cleared any clamping or any other obstacles.
Okay. So then we should be okay with the 1-inch lift, sounds like.
Yes, sir.
All right. All right, so if we look at the rough simulation here on the outside, so it's gonna do that, and then do a little lead out, and then re-pierce, and then come around, and then do that. Yeah, so in this case here, we might want to start the outside cut down at this corner so that the material is fully in the material as it's coming along here. Yeah, because if we do it like this as it's coming along, if the tabs weren't there or whatever, then yeah, the part could start dropping down at this point because there's less and less material that's holding that part into the material there.
Okay.
So let's go ahead and just change that actually. So they do have the this button here if you just want to change your lead position on a cut. So once you've added a lead, if you just want to change it, you can click on this button here, and then you click where you want to put the lead. If you want on this corner instead, we click. Then you just go through that same process as normal for adding the lead in and lead out.
Okay.
And then those tabs remain there.
And I'm assuming tabbing is the best way to fight pre-stress in a material, or
yeah, it'll keep it in there. So if the material does bow, at least it's going to move with the material versus like dropping down. And so it's just a matter of maybe adjusting the tab size depending on the thickness of the material. You should just have to kind of do some tests on to see what works best for you.
Okay. Okay, that makes sense.
So do you want to leave these tabs on here on this one?
Yes, that'd be fine. Yeah. That'd be fine. I can always take them out if I outside too.
Yeah, test them out, see how they work. All right, so what we'll do here is we'll go ahead and we already set our 0, 0. We'll go ahead and create it. I'll do this as a new part so you can have both versions.
Okay. Yep.
Tabs.
I knew I was basically overlooking the magic button to do it. I just didn't know exactly where it was.
Yeah, no problem. So let's see if we click on this, does it show us 3D end rapid? That's the end rapid. That's that cut. All right, so just kind of like get a graphical representation of approximately what this would look like if we were to draw in a 0.040, oops, radius 020 radius, and we do another one over here, 020. And if we measure from Q quadrant to Q quadrant, so there we got about a 40 thou gap there. And that matches up with what I had plugged into that dialog box when I was asking for the width of the tab.
Yes, sir.
So, and of course we can set our 0, 0 and click on our part button. Good. So this initial lift here of 1 inch, I've got basically hard coded into the post for any of the 3D 5X parts. Because if that wasn't in there, IGEMS has it going all the way to the top of your Z-axis travel. So the beginning of every program, it would go up like 10 inches, which I found that most people didn't like. So we'll lift 1 inch and then rapids over and does its thing. And then we lift up the inch.
Any idea on when you guys are going to resume, I'll say, traditional classes in Ohio, or not at this point?
Yeah, it's probably going to be a few months yet. I find that this training is more effective anyways. I mean, sometimes it's nice to get away, but I think when it comes to software, doing it like this, I think is pretty effective because we can answer the questions that you have right there at that time. Sometimes people come for training. I think it's a little bit overwhelming what we try to cover when it comes to IGEMS. The course is 2 days, and first half of the day we do basically like a water jet 101, theory of water jet, how it works, and then the afternoon on the first day is maintenance training, like pump seal changes and things like that, which people really enjoy. The morning of the second day, we do cover WardCam and IGEMS. So in about a 4-hour period, we run through a lot of software stuff. So it's good overview, but for like more in-depth stuff like we're doing here, I think it's better just doing it one-on-one.
And now it looked like the nozzle drove through the part after the micro joint. That after it did the lead out, when it did a lead in, it drove itself all the way down on both sides.
Yeah, that's a simulation. Is it a simulation thing? Okay, so that is pretty interesting there. So I'll have to look at that.
No, this is great because it's actually relevant parts to what I'm doing. You know, the way that we've built things in the past, so it definitely helps me as far as learning and not just making a part for the sake of doing it. You know, something that's applicable.
Okay, yeah, so I'll have to look at what's going on in the post there. Let's see if we do it, just because I'm curious, if we do it as a programmable Z, what does it do? Programmable Z. And let's see, comes down, does our vertical cuts. Huh. All right, well, I'm gonna have to look at that one, obviously. Lifting. All right, so don't do it through 3D5X yet. I'll look at that tonight.
No problem.
I tend to work on these things at night.
I understand. The phone doesn't ring and a lot of things don't happen in the night.
Yes. All right, so let's go back and remove those for now. So we go back into here and back into micro joints, and we're gonna delete that and that. Close, close. Update. All right, so we'll come back and revisit that one. So we'll just delete that for now. Go back in. Let me just grab a sample file here. Wow, this looks pretty similar to what you're doing anyways. There is also, when you're adding a, just do the auto for right now. Let's get something on there. Toolpath. Delete all for now. Sure, yes. The other, if you only need one tab on a part, when you do the plus button that we normally do, and you select your upper curve and you choose where you want to put the lead, and we hit enter and the direction, and then our lower curve, and then we put our lead in, and then for the lead out, I'll put a little lead out on here for right now. But if I change the lead out length to 0, and or in this case here, we do 0 overcuts, and we put a negative lead out length in here, turn off the lead out. So if you put a negative number in here, then that tells the jet to stop earlier. No.
I'd actually tried that because that was what kind of made sense just from some very oversimplistic view from what I was looking at. And I got that same red error.
Did they change that? I thought I used to be able to do that. Because we do overcuts, if we do negative overcuts. Yeah, negative overcuts, right.
Okay, so back the overcut up. Gotcha.
Yeah, so, oops. All right, so there it's stopping short, and then of course you can also adjust that as needed.
Okay.
So that's if you want to tab like that, and then of course you could always go back and just do one other with the micro joints if you wanted one somewhere else. So if you wanted one on another corner or somewhere over here. So
okay.
But there's a couple ways to add tabs.
Okay.
Let's see, close. We'll just close out of here. There. Oops. Yes. Exit. Are you sure? Yes. All right. Let's see now that other one that you were working on here. Right. Not sure what they got going on there. I personally don't usually use the automatic lead function.
Okay.
Just because don't quite have as much control over the way. There's a script in the background that controls the way the leads are done, and I haven't delved into that too much. So I usually, do these ones here, and so see if there's an outside one. So then what I would do if I want a tab is edit this, and then you can make a new tab type and call it, outside with whatever you want to call it, 060 tab or whatever the case may be, whatever you want to name it. And then you've got your linear lead in, you got your length of lead in, and then negative number for the overcut. And then that will leave the tab on there. And if you want, you can give yourself again a little bit of a lead out at 90 degrees. So come in, go around, and then stop short. So then you'd have something like that on there. And then we would just need to update that on these ones here if we want to do something similar on these other ones. Since it's nested, we just have to go around and do these individually, but you can also, there's a clone part command where, let me back up one step here. Whoops, undo.
But so you can delete that nesting. We can.
I'll show you in case it ever comes up, the clone command. Let me undo one more step here. Okay, I guess what? See if I've gone too far now. Redo. All right, so that's where. So it's updated this part, and then these other ones have the other lead.
Yeah, I see it now where it kind of comes back into the part.
Yeah.
Slightly.
Right. So let me remember how to do this one. It's under part. So there's the clone option, toolpath. There's also clone options. This will clone toolpath. So if I click on this and then I select, so this is the part that I want to clone, and then the parts that you want to clone that to. So then we can select the other parts, and then it'll just automatically update those with the toolpath that we had on that first part. So if you ever get into that situation where you do nest a bunch of parts and then you realize you want to change something globally on all those, then the this clone command comes in handy. And I think if I press F1, let's see what comes up in the documentation. Or see if anything.
And I am trying to read on the manual and watch as many videos as I can. I just kind of on the still trying to fight my way through the learning curve.
Yeah. And it might not apply to a part like this where you don't want to have any dings on this edge, but there is also, you can do things like chain cuts or what do they call it on the other one here under toolpath? There's bridge cuts where basically with like one pierce, you could do a bunch of bunch of parts and have it so they all basically are chained together. So let me just show you how that would work if it was something. Again, on this part where you want the lead in a particular point might not work, but there might be situations where this can be helpful. So let me just copy this over to here so you can see how this would work. I guess we'll do it as a bridge cut here. So if you want to do a bridge cut, first of all, we'd have to delete what's here. And we go into toolpath and bridges. And basically this defines your first lead that you're doing, your first pierce, and then whether you want tool left or right, and that's just going to determine which way it's going to go around the parts. And then the size of the bridge or the little tab that's basically going to leave on there. Geometry optimization, it'll look at the stream diameter and figure how tight it can get into small geometries. So we'll turn that on. And if you do multi, and then select the parts. If you do it as multi, it'll basically kind of make its own path, how it sees fit. Whereas if you do it as single, you can tell it the path that it's going to do. So you can kind of see here what it's doing here down at the, well, let me close this right now. So like I wouldn't be too crazy probably about doing that. So I would probably just do the single command and tell it specifically where I wanted it to put those bridges. So you do your bridges and you do single. So the first thing it wants to know would be for the initial pierce, the initial lead-in point. So we'll stick it on this corner here. And then what this little white line that's coming from my cursor basically is giving you an idea where the tab would be if you click. So if I left click there, it'll put that little tab in there like that. And then you can basically join all these together. And with one pierce, you could cut all those parts. Let's see. And there might be situations where you have to have two. Let's say you could do something like that.
Is using only one pierce mostly a time savings, or what's the?
Yeah. Time saving is a little bit of wear and tear. Of course, if you are going to have any sort of abrasive clog issue, it's usually going to happen on your pierce. So
Okay.
if you can minimize pierces and something like this, then less likelihood of things going wrong. Because usually once it's cutting, things go well. It's just I said most of the time if you're going to have an abrasive clog, it's going to happen at that initial pierce. So.
Okay.
So that's can be a bit of a time saver sometimes. So that's how that one works. The other option there that I was talking about was chain cutting, which can be useful also, sometimes more on thinner material. So if I were to draw, let me just draw something here. Say it's a 2x4, and I might do a bunch of these here. I'll just randomly space these across here. Something like that. That should be enough. All right, so I'm gonna go ahead and make my parts here. And that's all well and good. And add my tool path on there. So if you are gonna chain cut it when you're putting your leads, you wanna kind of be thinking ahead as far as where you're gonna place the leads. And I would put them in the bottom middle usually, or top middle. Because what's gonna happen is we're gonna come in and we're gonna cut around, say this first part here on the left, and then when it leads out, we're gonna come over this way and then do this one here. So if you have your leads bottom middle, then that minimizes that distance that it cuts between the parts.
Okay.
So, and I'll do these with the tab on there also. So I'll just, let me press F9 for my snaps here. Midpoint, 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 and midpoint. So once you've got that toolpath on there, you can use modify, chain, and then this would be basically the feed rate going from part to part, where it doesn't matter so much. So you can either do like extra rough or rough. Extra rough might be too fast. You might get water and abrasive spraying everywhere. So rough might be the fastest. You want to go between the parts. And then basically you left click on the parts in the sequence that you want to cut them in. Oops, sorry. How often I do this one here? Let's see if I did that wrong. All right, so then we got this whole, let me back up here because I did that wrong. Undo, made a mess of that here. All right, modify, chain cut. Okay, select parts. This, that, and that, and we hit enter. Enter again. All right, and then specify points. So this is basically you're telling it the rapid path from part to part. So if there was an obstruction there, you can rubber band this out. But if you're okay with just going straight across like it's going here, you can just hit enter and it skips to the next one. If that one looks good, you hit enter. And if that one looks good, you hit enter again. So basically it's gonna come in, pierce, cut around this, and then at the end it's gonna cut over here. And then, so again, one pierce, and you could cut all those parts, and you can have the tabs on there so they didn't fall in. So again, usually this might be for more thinner material like sheet metal, where you can,
yes, sir.
Where it's probably faster just to keep cutting and zip right across and zip around there. So those are a couple advanced techniques. And then there's also the potential of doing common line cutting, especially on something like this, where you can use one cut and separate the two parts. So if you did want to do common line cutting, you'll want to nest the parts and then add the tool path. So let me delete these for right now. Move this off the sheet for right now. 2468. All right, so if we go nest and we click auto and select those, and then the sheet that I want nested onto, and say that I want 8 of them. And down here at the bottom, you got the choice for common cut. So click on that and then click on nest, and then it'll try to find areas where it can put the parts together and have straight edges. Now, if you want to, you could always just force it to do a particular thing. So if I cancel and said, all right, let's do, instead of automatic rotation, let's do 90-degree rotation. And let's see how that looks. So that looks a little bit more like what you had originally. Stop and okay. So yeah, so it'll be able to do a common line cut here and then some other areas. So to actually apply the common cut, you go to the cam tab, you go tool path, common, and then usually I set this to sheetwise. So it would go through, do the common cuts, and then when it's done with that, then I'll go through and do whatever cuts around the part to finish it off. And then if it's gonna ever cross across somewhere where it's already cut, it'll slow down to make sure the stream catches up so you don't, the stream doesn't jump over the kerf width that's already there. And then you can specify your lead-in length for your pierce. So if we do this, and again, this may not particularly apply for these parts, but it might be something you can use in the future. And we'll do a simulation so you can see it. So basically it's gonna cut a little area there in the middle and then it's gonna do a pierce and cut along there, pierce and cut there, pierce and cut there, and so on. And you know, given the size of these parts where they're small and they might fall into the tank, you probably wouldn't want to common line cut these. But again, for bigger parts that have long straight edges, you can save some time by doing something like this.
Okay.
So let's see, we'll just delete all that stuff. Now for taper compensation, I think you had some questions on as far as adjusting that.
Yes. So I'm not trying to make this machine take the place of a milling machine. But the closer I can get to 90 degrees at some points when I'm putting together different fixtures or different components, the better off I am if I need to flip that tab, flip a tab up and drill and tap, right, to bolt it to another plate. So I wanted to at least learn how to move it. So if I had to I'm assuming I would probably need to cut a test part till I was satisfied with the way the cut works, and then determine that's a good taper comp and run the real part.
Right. Yep. And so basically what you can do is just drawing like a 1.5 by 1.5 inch square here. And I am going to just explode this so I can offset some lines. 1/2 inch, gonna make a little U shape here, or C shape, and then just trim this up. TC test piece. Where would you like to save this? You can go ahead and navigate to wherever.
There's a water jet folder just a little bit above. I've just been putting some sample parts in, so that's fine.
All right. So the idea here is we go into whatever material, do 3/4 inch stainless. Scroll down here, they have this little diagram. So what they suggest is basically cut a part like this that I've just drawn, and half of it you cut at the rough quality, and then this half of it you cut at the extra fine quality. And then you put in the A and B dimensions. So A would be top on the rough side, and then B is bottom on the rough side, and then C is top on the extra fine, and then D is the bottom on the extra fine. And you plug these numbers in here, and then these taper comp numbers will vary. So if you actually cut this and say you measured the A dimension, you measured at like 0.502 or whatever the case may be, and then the B, the lower side, 0.522, And then the C at the top, because as you go slower, your stream actually gets a little bit wider. And that's what this VOC thing is. It's variable offset control. So as it cuts slower, it'll actually change the tool offset a little bit to account for the difference in the stream width from the high to the low speeds. So you might measure it, and when it's cutting the slow area, that dimension would probably be a little bit smaller. You might find that it's like 0.502, and then the bottom here might be 0.512. And then you'll see as I click out of these box here that these numbers change. So then it basically interpolates those from the Q5 to the Q2 speeds there. So you can basically use these boxes here to fine tune your taper values.
And that's done per material and per thickness.
Right. Yep.
And okay, so once they're set, they can. So as I'm working through materials, and as I set these up, IGEMS is going to have that in memory.
Right, and you check this
so
lock
we don't
box.
have to do it every time.
Right, check this lock box, make sure that nobody is going to come in here or some things will get reset. But yeah, just once you're happy with it, you can check that box there. So if you cut a part, so we cut the first part and these were the numbers that I came up with, and then you cut a second part and there's still a couple thou taper, you would just come back in here and say, all right, we're going to say it was 514, and then you'll see as I click out of this box here that number is going to change slightly. So if you find that you do still have a couple thou taper, you can just add in a couple thou on the lower numbers here, and then the value, the angle will change accordingly.
Excellent.
So when you actually go to create the part, a couple steps you have to do to let IGEMS know what you want to comment or what you want to taper comp, because you don't have to taper comp all the cuts in a part. Let's just set this for medium for right now. We'll apply that later. And so if you want taper comp this, you go to part and you got the TAC lag here. And so since we're adding this to the part, click on and then click on the part and then hit enter. And then basically this entire part would be cut with taper comp. So if you ever need to turn it off, then you've got the off option. So now that we've done that, then IGEMS will know that, hey, okay, when I'm processing this, he wants to taper comp this. And
okay.
then we add our tool path on here. Let's see, I might want to spin this part around here. Let's see what happens. Yeah, we'll do it like this. All right, so again, we probably want this with, since it's small, we'll do this with the tab, so we'll use that one. So we'll stick the tab back here in the middle, and then we will change our qualities. So we go to our quality area, click on the part, and then we're going to do extra fine, and we're going to paint it. And that tab might be a little bit big for 3/4 inch. We can adjust that later. So I usually apply the Q5 quality from slightly before the end of the leads, just to make sure that the jet slows down enough. So we'll go from here to here. So that area there will all be in Q5, and then I hit enter, and then we do rough and paint that from here to here. So, and when you measure this, you basically want to measure kind of in the middle of each of these fingers. If you measure too far towards the tips, you might get some little bit of kickback from around the corner. So you're usually going to want to measure somewhere here in the middle of the fingers.
Okay.
So if I click on this edit button here and click on this, if I need to change my tab value, I can change it in here. So I think that's going to be a little bit big, especially if you do cut this out of 3/4 inch. Let's make it let's make it 10. Oops, 010, 010. That should be big enough where it's not going to drop in. 6 actually. Let me add a few to that. Make it 14. So as you change this number, you see this gap here changes. So we're going to have that around 0.10 of an inch.
Okay.
So we got that, and then we can set our 0 point. And we go process, and let me just see what we set your pressure at. On your pressure gauge, do you have a pressure gauge on your gantry?
Yes, sir.
When you're cutting, are you actually getting 60,000 at the gantry, or is it a little bit less than that?
There's a little bit of fluctuation, probably from 58,000 to 61,000.
Okay, yeah. So we'll put this at 58,000. All right. It's depending on how far away the pump is from the machine, there can be some pressure drop. Like on the machine I was using the other day, we had 52,000 at the machine because it's like 50 feet away from the pump. Anyways,
we're probably 20 feet away.
Right. All right, so we're going to strategy area. So we are still doing this with height sensor. And we go down to cutting. So we got TAC, taper angle compensation, and the variable offset control. Now lag doesn't apply for our current setup here, so we'll just keep that one as no. And then of course these here are those lift values on any of our 2D parts. This is what we're using for lift values between cuts and parts. So if you ever need to change these, of course you can change them there. All right, so if we take a look at this, so we got some angle there. All right, so we're gonna lift up. So we got starting at 0.32, and then it's going up to, looks like maximum speed at 2.02 and an angle there of 0.36 as it comes around, and that's gonna come around here. And then it's gonna come around to here, 0.36. And then when it goes around the other finger where it's going faster, then these A values, of course, increase based on that speed there for a maximum of 0.65. So that would give you a little test piece. And let's see, yeah, we got our delays on there. So, do you want to cut one of these?
Yes.
We'll go ahead and save that. TC test piece. Oops. 0.75 stainless steel. Test one. Did it? Oh, this box not checked. Let's just make sure. Yes, okay.
And on the part created in 3D 5X screen, under that toolpath is where we can also check that paper compensation.
Right.
Okay.
Yep. Cancel out here. So again, if you wanted to, you could test it with and without the variable offset control. Might as well turn that on so you can see how that works. So let me do that here. Test one. This is TAC and VOC, variable offset control. See, documents, water jets. So if we open each of these, compare. Oh, here it comes. All right, plugins, compare. Let's see if we see anything different here. Did I compare? That was different.
What part do you want details? That white one.
Let's see. See that again here. They're both. Make sure I didn't do it on. Process. If we don't check it. And get rid of one. All right, there we go. All right, so I think on the first one I had applied. So you see there's a slight difference there in the those values because of the that variable offset control.
Okay.
So that's why these numbers are all shaded slightly differently.
And you said the variable offset control is working when it's turning corners and
any change in speed. So
changing
yeah, when
speed.
it's
So
yeah, so
deceleration, accelerations.
Yep, yeah, when you're coming into corners or this side versus this side, especially where you got a big speed change. So
So that'll also help in the instance where I've tried to do some holes that I plan on tapping afterwards, and the hole size looks pretty good. There's a little bit of draft, but I probably know more than what a drill bit has anyway. But it leaves a little hanger, little bump right at the bottom.
Yeah, I'll probably help with that. You could also try doing a little bit of a little more over travel or overcut on that. Let me just bring these files in here. So this is a little utility that allows you to bring in a CNC file. Let me bring in the other one here. So let me just go ahead and clean these up here. So if I change just to help distinguish the colors here, make that one red, make this one yellow. So the yellow one had the TAC VOC applied to it. So if we move this from, let's see, this endpoint to this endpoint. So if you zoom in a little bit, you can see a little bit how those two lines vary slightly.
Yes.
And then if you look in the corner here, so it's offsets more there because it's going slower, and then as it speeds up, it's actually those two lines actually get closer together. So it's kind of a neat little thing that they've come up with.
Yes, sir. So running TAC VOC, does that necessarily slow down parts if there were, or it really does not? It just helps us get a more accurate part. It's all said and done. Is that safe to say?
Yeah, right. Yep. Yeah, it should be straighter edges and closer tolerances.
Okay. Excellent.
So yeah, so then as if you cut one of these and you find out that there's still a couple thou taper, you can come back in here, go back into your material. And so if you still had a couple thou taper on the extra fine, then you, rather than saying, all right, maybe it wasn't 512, maybe it was 514, and then cut another one, and you'll find that it should be a little bit closer. So
Okay.
So, let's see. For
So we
whole
cut a
quality.
regular part. We cut the regular part first, right? So it's just without no TAC, no VOC. We cut that,
Right.
measure it, and then enter those values into that screen,
Yep.
lock that screen, and then we're able to run a part with TAC, VOC on, and it should basically eliminate majority of the paper. Okay.
Yep. Yeah. So if I do one without it, turn that off, and put this on. No OTC or VOC. So you could do that one as your first one that wouldn't have anything applied to it, and find out what those actual values are. So if we look at this one, it shouldn't have any sort of oops, wrong button here. So if we look at this, oh, that's nice. Why is that happening? Okay, let's look at it here. So that's this one over here. So this doesn't have any sort of ANC motion in it since I turned off the TAC. So yeah, you could do this one as your first one, find out what the actual numbers are, plug them into those fields in the material file, and then cut another one, and then adjust a third time if needed.
Excellent.
So for hole quality, the nib on the back, let's see if you go in and, so if we create a part here, and sure, all right, so contour. So on the inside hole, which would be the internal here, so this is what it's using for the overcut. So you could adjust this to try to improve that. The other thing you can do is if you're cutting most of the part at one quality, you can use that paint command and have it slow down more at the end to make sure it slows down enough. So like this hole here we're already slowing down extra fine. But if you had most of this hole being cut as the medium or the fine, you could use your quality command and use extra fine and paint and basically click a couple points and just go slower as you approach that lead out point. So there's that. In the material file, you can slow down, adjust how much you're slowing down at the end of a cut. So each of these materials, you got your high speed and your low speed. So if you click on this edit button here, you decide, hey, I want to slow down a little bit more at the end. You can say, all right, let's slow down instead of to 1, let's set that to 0.8. And then it'll slow down more at the end of the cut.
Okay.
So usually what you'll find, of course, is as you're going up in speed, you'll get more of that nib because you're going faster when you approach the end of the cut. So usually the extra fine end of things, you may not need to adjust things, but if you are trying to cut your holes faster, but you want to improve that nib, then you might have to reduce these numbers. Let me set this back to default. Sure, yes. And show you actually one thing that they've added recently. They've had over the years, they've had a couple different algorithms for calculating these feed rates. And they just added this new button here, Old Auto. So this is going to give you a little bit more conservative feed rates. So you'll see when I click on Old Auto, you'll see these numbers will probably go down a little bit, and gives you this warning here. So we're not using TVL in its entirety, so we'll just say okay to that. But you see how now this is 1.79 and this was 7 versus it was 8 point whatever. So the old auto, as I said, will be a little bit more conservative with those feed rates. So you can also try a couple different parts between the two and see which one works out a little bit better for you. If you want to revert to the newer, more aggressive feed rates, you can click on Edit. All these numbers are in red, showing that they've been changed. You click on Default, then it'll go back to what we had there originally.
Okay.
Any questions on all that?
I'm sure I will, but right now everything does, I think, make sense. I'm gonna have to do a little bit more in it to continue to learn more. Now, one of my next questions is, and I'm not trying to interrupt you and what you're trying to show me, but it is on lead-ins. So a lead-in for a hole, you know, everything I've always seen in plasma, oxyfuels, and others, the lead-in is always more of a radius lead-in instead of a straight in and then start turning in the hole. Is that just different on the water jet? It's not necessary? Does it help anything?
We usually find that on metal, a straight line lead-in tends to work out a little bit better because it kind of forces the jet to slow down when it comes to that sharp corner. You know, if you get into doing some really thick stuff, 6 or 8 inches thick, then you might find that the arc lead-in gives you a little bit of benefit. But usually for, I think what you'll be doing, this straight line lead-in is because it'll come in the lead-in, and when it gets down to the end of the lead-in, it sees that turn and it's going to slow down to its low speed. Versus an arc, it's going to move at a little bit higher speed going in there.
Okay.
Certainly, if you want to try it, there's the you can set up a new lead here. So if we set up a new lead and I'll call it arc, whatever you want to call it, just in case you want inside, outside. So if you want to do that, so you choose your piercing type, you can choose your length of lead in, and then then you got your radius field here that you can experiment with some different radii leading in there, and then a little bit of if you want to give yourself a little bit of a lead out, oops, 0.08 or whatever the case may be. So come in, arc in, and arc out, and then it's also got of course the overcut on there. So
okay,
can certainly experiment with that, see what works for you.
Well, I was just asking. It wasn't that anything's not working. It's more of a curiosity.
Yeah. Actually, let's make this. That'll work.
I trust the experience that you guys have.
Yeah. And then also, if you find that you have, like, there's a certain type of lead that you want to use on thin material and a different type of lead that you want to use on thick material, you got this favorites button down here. So you can click on this and you click on save and you can give it a name, and then you can easily switch back and forth between different setups if you do find that you've got preference for different leads on thin and thick. So let's see if I close this. So if we draw a little part here, let's do a diameter, 1 inch diameter. Oops, let's do a rectangle.
So with a 40,000 nozzle with this setup, what's the smallest accurate hole that you could actually cut?
You can do a 1/8 inch hole fairly reasonably, and there is a under this toolpath submenu. There's this hole options, which can create a pretty nice looking hole because it goes around the hole like 3 times.
Mm-hmm.
Obviously, it takes more time to do that, but it does give a quite nice quality hole. If you want to do, let's try a little test on that here. So if you want to do that, you can set up a part like this, and we'll put this on here. So the way to do that, you go to your tool path, you got holes, and we'll switch this to be, what is it here? Cutting. Okay. So basically, I choose filter. Let's see, I want to choose this as my filter. Select objects. So if we put a toolpath on here, just for right now, and we take a look at this, probably wouldn't need to do taper angle compensation on it because it's what it's going to be doing anyways. So basically come in and it makes one pass at the high speed, and then it moves out slightly, and then it makes another pass at the slower speed, and then it goes around a third time again at the high speed. So it ends up being a pretty nice looking hole. Just takes a little bit longer to do, but I've got some nice like 1/2-inch holes and 1/2-inch material by doing that.
So in a very thick piece, that would be a good thing to try.
Yeah, it's worth giving it a try.
3 or 4 inch piece.
Mm-hmm.
Okay.
So if you wanted to try cutting this, we could put another lead on here and make sure it's got a little tab on there so it fall through. Let's change that back to dynamic. Let's do another one here. So, let's see, new. Oops, my cut sequence is bad. No, that's okay. Yeah. Inside cut, outside cut, that should work. So this would be an example where if you did want to do, we don't necessarily need to do taper compensation on the inside hole, but you might want to do taper compensation on the outside hole. Then again, on the parts, you go into the TAC lag thing, click the on button and say, all right, just do taper compensation on the outside. So that way, if we did this again, leave the TAC on, and oh, it's got a rewind in there. Okay, gotta change my lead position. I don't know if you're coming across this yet, but depending on where you put your lead, you can get a situation where, depending on where the C angle starts, you might get a rewind in the part.
I think I did on one part in the simulation, but I haven't run that part yet. And I realized it was probably because where I put the start point.
So usually if we're coming in from this side, probably be better. Let's see. Close process. See if we get that again here. TC. No rewinds, that's good. Okay. So yes, that'll be cut without.
Does a rewind really hurt anything, or is it just a stop and start point?
Yeah, start and stop. So you'd see a little bit of a blemish there where it re-pierced.
Just a little witness mark from the.
Right. Yeah.
Okay.
So if it's not a critical edge, then you could go with it. Obviously, if it's something that's critical edge, then you'd want to change things. All right, please hit yes. Okay. So you could try that, see how that looks out of 3/4 inch. What else would you like to cover?
So I don't need to do tabbing on 3D5X. I need to do tabbing, or not through the micro joints. I need to do the tab through a negative overcut.
Right, and
for right now.
Hopefully by tomorrow morning I'll have that figured out.
Okay. And that's not a problem. I'm just making sure I got my notes correct.
Oh, I should mention
Probably in,
one other thing
sorry,
on
go ahead.
tabs. If you are doing a part out here in the 2D world, of course we know how to add our tabs like that. But if you did want to do a second tab on a part, let me just draw another part here. So if we want to put all right, so let me put one down on here. All right, I will do tab single. So if I put one here, and then if I want to tab somewhere else on the 2D part, you go into modify, and then you got the micro joints here. And then similar to that, what we were looking at in the 3D world, you can define what you want for length of lead in and the gap and such. 0.02 or whatever the case may be, lead in length, lead out length and such. And then use insert, and then you can put it where you want it. So.
Okay. And I saw that in one of your webinars, and that's, but when I'd already created the part through the 3D 5X and then come into the 2D world, it will not allow me to add that in the toolpath, and that's where I couldn't figure out what I was doing wrong.
Yeah.
Okay. Makes perfect sense.
And this should work. It's going to come up over, and then it's going to height sense. Yes, Luke. Go potty.
You got a 3-year-old?
He's 7. He hates to go to the bathroom because he's like absorbed by all of his videos, and he's like to the point where he's almost going to pee himself, and it's like, emergency.
That's what my little girl does. Sometimes she gets really tired, and she's so tired, she's so engrossed in it, and all of a sudden she looks down, she's like, I made a mistake.
Right. All right. Any other questions for today, or?
I think that takes me a long ways right now, Mr. Jeff. I'm going to have to probably encounter some other challenges myself before I know any good questions to ask. Unless you got anything that just based on our general conversation you think we should, go over. I'm just going to have to spend some more time on the machine again.
Right. Yeah, pretty good for now. So, as usual, anything comes up, let me know.
Thank you very much for your time, sir. You have a good afternoon.
Right. Thanks, you too.
Take
Bye.
care. Bye.